welcome to Chapter 8. This chapter is about strings. Now you may be thinking, well, we covered strings way back at the beginning of the course, and we did. But now we're going to look at strings as an object, which is why I've brought up this JavaScript object string reference page. As you remember, objects have properties and methods. The objects describe the string. The methods do something to the string. So you can check out this object reference on your own and see the different methods and objects that you can use with string. Let's go ahead and demonstrate a few of them. So declaring a string is nothing special in JavaScript. We just got to say var, the name of the string, which we'll call phrase, equals if you are strong enough. Got to spell everything right. There are no precedents. All right, so I'm going to put a semicolon, end that line. So that's our string that we're going to work on. Now, if I want to get the length of the string, it's as simple as document write string dot, not string, but phrase, which is my name for the string, dot length. And you may be noticing here how Komodo gives me this little bit of help and has all of the relevant methods and properties in here. So with a triangle, that's a property, and then with the green circle, those are methods that I can use. It's very helpful if you don't know the exact name of the method, but you know what you want to do. It's also helpful if you know multiple languages and you can't remember the exact syntax for JavaScript. Let's prepend this with length. All right, so we save that. Let's take a look at that in the local browser. And the length is 49 characters. That makes sense. So length is a property of the string object. Let's take a look at some of the methods that are available for the string object. The first one is character at. And character at gives us the character at a specified position in the string. So let's say I wanted to get the character at every position. We'll loop through the entire string. So I'm going to do a for loop. So our counter will be called I. I is less than phrase dot length. And then we'll increment with I++. And so each time through, we'll document write where we are in the string, which is going to be I. Put a colon after that, make it readable. And then we'll put the actual character at that position. So for that, we'll use phrase dot character at, and then the position, which is I. We better add a break, otherwise that's going to be very hard to read. All right, so there we go. So at position 0 is the I. It's kind of like an array of characters, isn't it? Actually, in some languages like C, a string is an array of characters. So we start capital I, position 0, position 1, and so on. Note that the spaces do have a position in the string. So that makes perfect sense. So we've looped through the entire string, and we've output the character at every position. We can also output the character code, the Unicode of each character at the different positions. So here, I'm going to add to this document write, and I'm going to go ahead and put here, let's put a pipe symbol to separate the two, just like that. And now I'll hit phrase dot character code at, and again we're dealing with position I. When I save, you'll see that these are the Unicode values for each of these characters, 73, 102, 32, and so on. These Unicode values can be useful for certain manipulations of this particular string. Unicode values in the old days were ways in which we could alphabetize strings through sorting, since lower characters had lower values. Notice here, a lowercase a is 97, a lowercase e is 101. Even the characters that aren't on your keyboard but are part of the Unicode character set have individual values. All right, so we've done character at, we've done character code at. Let's just do a couple of more. Let's say I wanted to find out where something occurs in the string. So I can use index of. So let's find the index of a lowercase s. So we'll document write index of lowercase s, and then we'll use phrase dot index of, and I'm going to put here, I'm going to put that in position, excuse me, I'm going to put that lowercase s right in here. The second argument, which you see here in the yellow help position, is if I wanted to start this searching later on in the string. All right, so I'm going to put a semicolon here, and let's see what we get if I scroll to the bottom. So the index of the lowercase s is 11. Let's check position 11, and there it is, lowercase s. So the index of returns the character at a specific position. Pretty easy to use. Now, another method is the replace method. With the replace method, that searches for a match within the string and replaces it with something else. Now, the replace method actually takes two arguments. The first argument is a regular expression or substring. So that regular expression or substring is what you're looking for. Now, a regular expression, if you haven't heard the term, is simply a character matching technology that's used in almost every programming language. Regular expressions are beyond the scope of this beginning course, but if you are interested in learning about them, there's a lot of resources on the web. And if you know them from another language, you can apply them here. So let's go ahead and let's document write. And I'm going to put in here phrase dot replace. Now, replace has two arguments, what we're looking for and what we're replacing it with. So let's look for strong and replace it with attractive. And this will output the result. Let's also get a break in right here so we have neat output. If you are attractive enough, there are no precedents. I'm going to add something to this. I'm going to add another break and document write, just plain old phrase. And there you get, let me add the break in there, which I didn't do. Great. So if we run out phrase again, it says if you're strong enough, there are no precedents. Well, wait a minute. I'm confused. Because here we said on line 24, phrase.replace strong with attractive, and we saw the result right here. So what happened when we outputted phrase again? Well, phrase.replace returns a string, but does not mutate the string in memory. So what that means is this particular string called phrase doesn't change, but it returns a value. So it returned the value here to document write and output the replace string. If we wanted to capture that, we would have had to set some variable and assign the phrase replace to it. All right, so we've looked at a couple of different methods. Let's look at just one more, and that's going to be the split. So let's say we have here, we have a string that looks like this. Let's call it names. And let's go ahead and give that list of names and separate it by commas. So Mark, Bob, Tom, Brett, Mary, Lester, and Charles. Now, this is just a string that happens to have commas in it. But a common way that we get information is in a comma-separated value format. So while this is just a string now, using split, I can easily convert this into an array, because the split method allows me to take an object and split it into a specific array. So let's go ahead and take the string and let's split it. So let's take var more names equals split. Now the first argument, oops, I have to do phrase.split, excuse me, names.split. So the first argument of split is the separator. So the separator is the comma, and then second is the limit. Now I'm actually not going to use the limit, so we're just going to return it like this. So this returns an array. Now more names is now an array. So I actually could loop through more names for var x equals 0. X is less than more names dot length x plus plus. And now I can output more names using our strings syntax like we did before. Document write more names, and then the hard brackets for an array, and that should be x because that's what we're using as a counter. Let me just add a couple of breaks here. We're going to cheat and copy and paste. It's not cheating. It's actually a good programming habit. All right, and let's scroll down here. And here are the names listed as we went through the array. So let's look at what happened again. We created the names variable with a comma-separated list. Mark, Bob, Tom, Brett, Mary, Lester, and Charles. I ran the names.split method and split them on the comma. Now, since this returns an array, I gave that array the name more names, and we went ahead and assigned that to the return of names.split. Then we looped through the array, just as we've done previously, starting at the 0th position and going to the end of the array using the array.length, and we added 1. So more names, first time through it's more names 0, then more names 1, then more names 2, and we looped through and got arrays. This is really helpful when dealing with data that is in a comma-separated values format.